Okay, in this tutorial I'm going to show you how to use the radiance section of the workflow to perform a daylight analysis using passive shading. Over here we choose the BSDF files that we want. We've already loaded in our BSDF files over here. You can use your own ones if you want. You just put the path in these boxes. I've connected this MicroShade A to the list component up here. So that is the one we're using in this video. We're using the BSDF file to create a radiance material using this component, and then connecting that to a window group over here. Make sure the blinds section here is disconnected from your window group. We connect the windows to this data point where the rest of the geometry is also connected to. Up here we have the different parts of the geometry. We have the floors and the walls and the ceilings and the frames. And then for each type of material, you specify the reflectance. We've done this according to the EN 17037 standard, and then chosen the middle value in the spectrum for each type of material. And then we connect all of these into one data point and all the way over here in our run radiance analysis component. We also, over here, we create the analysis grid. This is done according to the EN 17037 standard as well. 0.85 meters above the floor and with an offset of 0.5 meter away from all the internal walls. We defined that test geometry in the prior video on shared assumptions. So we create the analysis grid here and the analysis recipe. This is a 5-phase daylight analysis, which is defined here, and we have the radiance parameters down here. I'm not going to get into details with those. And then these are connected to the run radiance analysis component here. So now I'm going to double click these two toggles to write and run the simulation. And I'm going to pause the recording while I do that because it may take a while. Okay, now the analysis is done running. Our output from this radiance analysis is illuminance values for the room. You can also choose to get radiation or luminance values if you do so in this component over here before you do the simulation. We're going to use the illuminance values to calculate the spatial daylight autonomy using this component from Honeybee Plus. Make sure the blind states is disconnected as we're only using passive shading in this video. The occupancy schedule is a bit special since we're doing it according to the EN 17037 standard, and that standard states that it has to be based on the 50% of hours with the highest levels of diffuse horizontal illuminance. And we're going to do that by taking as an input the diffuse horizontal illuminance from our weather file, which has to be the design reference year data. And that's the input here, and then we create a binary schedule based on that, same as we did before with our radiation values, except now it's based on the daylight hours. And we use this component from Honeybee to create an occupancy schedule from that, which is then the input in the spatial daylight autonomy component. And then we get an SDA of 51.5 in this case. We've also included an option up here where you can calculate the UDI with your own parameters if you want. So that was a quick run through of how you do a daylight analysis with passive shading using the workflow.